For this tutorial, we're going to take a look at order of operations. This should be review material for any high school student, but sometimes you need a refresher on these things. As you can see, I have the standard Canadian acronym for order of operations over here on the right, and that is BEDMAS. So most of you took this operation or learned this in Canada would have learned it this way. BEDMAS stands for brackets, exponents, division, multiplication, addition, and then subtraction. I've also listed to the right just a reminder on the order that you should be doing these when you encounter each type. And as you can see, most of them you simply do them left to right. The only exception to that is brackets, because of the way that brackets form. There's a left bracket and a right bracket. You can see that over here in my example. And so for brackets, you're going to want to do the inside brackets first, or the most inside, and work your way out to the most outside bracket. Now, as you work through brackets, you may actually have to also go through some of these other operations in their correct order. And we will do an example, a more advanced example, where we can see that. So let's go ahead and get started. Take a look at the example we have right now. And the first thing I notice right away, I go looking for brackets, and I find a set of brackets right there. So I have to take care of what's between those brackets before I do anything else. Now I'm going to do this one step at a time, and until you get really good with this, even if you're a more senior student, if you struggle with this at all, you really want to take your time on this. Now I've chosen an example that I should be able to do without a calculator. That won't always be the case, but the procedure is still the same. So we're going to take our time. We're going to say that this is equal to, and the first thing I'm going to do is I'm going to take a look at what's inside this bracket. So inside the bracket, actually, before I even get to that point, just erase that, I want to take a look inside that bracket. Well, what am I going to do? What operations do I have inside that bracket? I have a plus and I have a minus. I have an addition and I have a subtraction. So addition and subtraction, we do those left to right, and those get done together. So it's not you do all additions and then all subtractions. You actually do these as you find them left to right. And while I'm pointing that out, I should also point out that division and multiplication work the same way. You do division and multiplication as you find them from left to right. So in this case, I have this addition and this subtraction. Those are the only operations inside this bracket. So in order to resolve this bracket, I'm going to do this addition first, and then I'll do this subtraction second. So we end up with is equal to bracket, and I'm going to put that bracket completely back, and I'm just going to go ahead and copy out the rest of the problem as it is written. 4 times 3 plus 2 to the exponent 2. And now what do I end up with in here? So the first thing I'm going to do is the operation 15 plus 18. So from that I end up with 33 minus 5. So you can see this first operation, 15 plus 18, turned into the number 33. And from there equals, we have 33 minus 5. So once again, I don't really need to do this, but I'm going to go ahead and I'm going to put my brackets back in place. Divided by 4 times 3 plus 2 squared. And I look at 33, excuse me, minus 5, and that's equal to 28. So the result of my next operation is 28. And so now what I really have, and I didn't need to write out this line, but what I really have, because these brackets now are fully resolved, there's no more operations to take place in there. So what I really have is the number 28 divided by 4 times 3 plus 2 squared. So if you wanted to go straight from here to here, that would certainly be a reasonable step to take. You don't need to write that extra bracket. But again, let me caution you, don't take shortcuts until you are completely comfortable with what it is that you're doing. Okay, next step, and like I said, I'm going to do every step here. I'm not going to skip anything. So my next step is to identify what is the next operation that I need to do. Do I have any more brackets left in the expression? No, I don't. Now I go looking for exponents, and you can see I have an exponent here. Exponent is that small number in the superscript, or a small number written above and to the right of a larger number. So I'm going to do this operation. I'm going to rewrite everything except for the operation I'm going to complete. 28 divided by 4 times 3 plus, and then what is 2 to the power 2, or 2 squared? That is 4. Now I'm done that one, I'm going to switch to another color. I'm not going to rewrite this in blue, so that's the operation that just took place from here to here. Now, let's switch to another color and take a look across and see, well, what's my next operation? What operations do I have remaining? I have a division, I have a multiplication, and I have an addition. So brackets are taken care of. Exponents are taken care of. Now, division and multiplication, I do those from left to right. And that means that this division is the next one to take place, because it occurs from left to right before this multiplication. There's going to be a temptation when you're doing these. You're going to want to do maybe the easiest operation first, or you might want to do the operation that makes this problem easier for you. That 3 plus 4 is awfully tempting. That's pretty easy to do. Or even this 4 times 3. Don't fall into that trap. You have to follow these rules to the letter. There are a couple of variations that you can make that let you work around that, but that only comes from being really familiar with these rules. You're not breaking the rules, you're just finding a different way to apply them. And we're not going to be looking at that here, just the basics. So I end up with 28 divided by 4. Well, 28 divided by 4 is just going to give me the value 7 times 3 plus 4. And now cycling around again, I take a look at my new expression. I see I have a multiplication here. So that's going to be the next thing I have to deal with. And so I end up with 7 times 3. That's equal to 21. Oh, I should have changed the color for that. So 7 times 3 is equal to 21 plus 4. And then I end up with is equal to 21 plus 4. Last operation is obviously addition, and I end up with my final answer of 25. So if you need to, go back in the video, rewind, and take a look, go through that again. Now I'm going to move on to a more advanced problem, and I'm also going to show you an alternate form that you may be familiar with depending on where you've been educated. I've seen more of this representation in notes and videos and explanations coming out of the United States. It's just another acronym that helps us remember order of operations. You can use whichever one you're comfortable with. I'm just mentioning it here so that you don't come across a different one and wonder, well, where is this coming from? So brackets, the actual mathematical, technically this is more correct because the mathematical term for brackets is actually parentheses. And then we got exponents. Multiplication division, as I said before, because multiplication division is just left to right regardless, it doesn't actually matter how we write this in our acronym. MD or DM, that part doesn't matter. And the same thing is true here for addition and subtraction. Doesn't really matter because the two of them, now it turns out this is the same order that we had before. Now, if you take a look at the actual example we have here, this is a much more complicated example. I have different types of brackets here, and so that can cause some confusion. When we're dealing with parentheses or with brackets in mathematics, we can use several types to help us enclose our mathematical expressions, and we sometimes mix the types to help us actually keep them straight as we're looking at the problem. So in this case, you can see I have some parentheses that are your standard curved or round parentheses or brackets, and we have some square brackets, and we also have what are known as brace or curly brackets. And those are the three common types. You'll see there are other ways of bracketing expressions, but we generally only use these ones when we're dealing with algebraic expressions. These are the three that you'll see. Some people don't like to use the brace bracket or the curly bracket because it has a special meaning in other types of mathematics, but we'll go ahead and use that here for now. So a much more complicated problem. So the first thing we have to do is identify parentheses or brackets. Well, there are plenty of brackets here. So now the thing we have to do is we have to say, okay, so what is the most inside set of brackets that actually has some sort of operation involved. When you see things like this, when you see things like -3 in a set of brackets, well, that's actually just the same as the number -3. In this case, the brackets are just here to provide clarity. They're there to provide, in this case, you can see we have it's something, something, something plus -3. And the reason for that is because we don't want to write plus -3 like this. That's a no-no, because that's confusing. A plus and a minus together like that is something we don't allow. From a communications point of view, representation, that is incorrect. So that's why we're using a bracket there, in order to just to provide clarity. And you can see that's actually happening in a number of places. This -3, this -3, this -7, this -14, this -8. We have a bunch of negative numbers here, and we're using brackets to provide clarity. So where are some brackets that are actually being used to contain an operation? Well, if I take a look, I've got a open square bracket and a closed square bracket. So there is a big bracket containing a bunch of operations, and that's going to be my outside bracket. I've got this -8. Well, there's no operation there. All right, here I have a curly bracket or a brace bracket. So I'll change my color, and I've got a set there. And it looks like, and then inside that I've got a -14 and a -7. So I can actually say, I'm just going to erase this stuff in case I want to do some rough work down here at the side. Whenever you're doing rough work, there's nothing wrong with doing rough work for questions like this. Just make sure that you do it off to the side. You don't want that. Even what I've drawn here, if you need to draw some things to help you keep track of what you're doing, that's okay. But really, you want your solution to be as clean as possible. I'm going to go way over here to the left, give myself lots of room to write some stuff out here. And I'm going to rewrite that square bracket, that -8, minus, and now I've got whatever the result of this curly bracket is. So I'm just going to go ahead and rewrite that curly bracket. Now if you pay close attention, you can see that curly bracket is actually cubed. So I'm going to put the cubed back in there. That dot, that's another way to represent multiplication. When you see a dot along the center like that, -3 plus -3. Now let's take a look at what's inside that inside that curly bracket. We've got a -14 in a bracket divided by a -7 in a bracket. Well, that's the same as -14 over -7. We could represent that as a division. We have a negative divided by a negative. That gives me a positive. And we have 14 divided by 7. That gives me 2. Now, I don't normally represent +2. A positive number is normally just represented as 2. So here I'm going to say that's a 2. That's what goes in that bracket. So now we go back. Once again, we just completed one of our sets of parentheses by doing a division inside that set of parentheses. Now we go back to the beginning. We look for more parentheses. In particular, do we have any parentheses that have any of these operations? Take a look. This -8 is just, that's just for clarity. That's just to contain the negative. This 2 is now on its own inside there, -3, -3. So actually, oh, I did not write, there is another set, which is, there is the end of this square bracket, which I forgot to write. Pardon me for that. So I do have inside now, so this is where I'm going next. Now I have to do this, what we identified before as the outer bracket. So I've got this -8 minus, I've got this brace bracket or curly bracket cubed. Well, there's nothing to go on inside here. That's just the number 2. So now the next thing I need to evaluate is actually that 2 cubed, 2 to the power 3. So although I'm working on this square bracket, the next operation that I'm going to perform is right there. It's 2 to the power 3. So once again, equals square bracket, -8 minus, now what is 2 to the power 3? So now this is getting rid of the bracket. Now it's the number 2 raised to the power 3, which is 2 times 2 times 2, which is equal to 8. Close my square bracket. center dot, which stands for multiplication, -3, -3, is equal to, now I have, and I'll go back to another color, I've got a square bracket to deal with. So the result of that square bracket times -3 plus -3, and -8 minus 8. So -8, so you imagine -8 on the number line, subtract 8 means go 8 further to the left. So we end up with -16. My next operation, I've got a -16, it's just a number. This dot represents multiplication, and then a plus sign, which is addition. So the next thing to do is going to be this multiplication is equal to, and so what is -16 multiplied by -3? A negative times a negative is a positive. We don't write the plus sign there. If there's no sign written, we know it's positive. And 3 times 16 is equal to 48. So we end up, this whole thing turns into 48, and then left over on the end here is -3. If it helps you to write these things to keep them aligned, you go ahead and do that. Just make sure you keep things neat, make sure that things make sense. And our last operation, so I can just go ahead, I'm ready to get to my final answer here. 48 plus -3 is the same thing as, and I'm going to write an extra line here, that's the same as 48 minus 3 plus -3 is the same as subtract 3, and that is, of course, just equal to 45. So, as you can see, order of operations can be handled even in fairly large and complex problems so long as you take your time, break it down, and make sure that you don't rush through things. Just take your time and do each operation in the order that they're supposed to be done.